Now if you look at the crutch from the top view and you were to picture in this hand wanting to hold something steady and grab the motor, and the motor wants to torque and twist, we want to complete the box in this dimension too. And what we're trying to do, in essence, the essence of what we're trying to do is connect this corner to this corner. We're trying to complete that. When these things are forced against each other, what tries to happen is you try to move these corners. Anytime you've got, if you had a nobler wing, here's an easy way to, typical nobler or a built-up wing. With the open bays, all you have to do is twist, hold the body, twist the wing, and you'll see wrinkles in this corner. Twist it the other way, wrinkles in this corner. So it's that torque reaction that we're looking for. Now imagine, the better you make this, the stronger it is, the better chance there is that you'll have what I think is a reliable, good quality motor run. And what we're banking on with the 90 is to have a really bulletproof motor run. That's one of the things we're really hoping are going to happen here. Now if you look at some of the old planes from the 80s, one of the things these planes had, they had no cowling. Extremely, extremely rigid nose, no cowling. The tank went in through that cowl scoop. Now in our case, that might not be exactly the most appropriate thing, because we're dealing with a bigger engine and we're going to want to have the convenience of being able to take it out in and out a lot easier. This really was an ordeal getting all these parts in and out. You had to use forceps and tongs and things, but it was possible to build a concourse Winning plane. In fact, we built two of them that had no cowling. But what I wanted to make the point is, and this is what I learned, and certainly not some kind of secret high-tech technology, these planes like tradition that had no cowling, this nose, even after 20 years of flying, I don't think, and after retrofitting engines and everything, that nose was still rock solid. Now a lot of people think, and they think incorrectly, and this is the time at which I have to think about it. You're designing or building or modifying a plane, and here's what they do with the nose. Let's say this is going to be the shape of the nose. They decide to make the cowling, well, that's an okay thing, because you still have the box. The tank box itself, the part that completes the box, you still have that integrity. Right up to here is where the integrity ends. Now, as the cowl gets bigger, you run the risk, and it's always a risk. Sometimes it'll work, sometimes it doesn't. As this cowling gets bigger, let's say you make it that size. Oh, but I want it to be real cute. I make it that size. Well, the bigger you make the cowling, the less integrity you have of the part, the smaller in essence that box becomes. So one of our objectives here is to minimize the impact into that box. I'd like to have that box a solid part of the wing, of the fuselage, because it's going to connect to the wing right here, and this is going to be the part that counts. Motor's going to be mounted here. It's this integrity that I'm looking for. I want it to take this torque, transfer it into the wing, and have a solid mount to the wing. And if I accomplish that, the bigger and bigger I make the cowl, the more chance there's going to be that I'm going to wind up with some kind of vibration issues. So to make the cowl as small as possible and to not cut into the tank box while we're doing it, those are the two things that I'd really like to accomplish with this while I'm going to massage this nose section waiting for that part from Richard. And I don't want to rush any part of this. I want to have this part in-house, because the alignment of all this stuff is getting that nose. Once that nose ring is in place, I can carve the top block, I can lay out the cowl. But I need to know right now how this is going to play out. And I sure don't want to make the cowl, especially for this ship, any bigger than it has to be. The smaller the cowl can be and still be able to get in there and do all the maintenance, I think the better chance you have of getting a good, reliable, solid motor run. And one final point before we go start cutting some wood. When I lay out a nose section, now let's use the Spitfire as an example because we've made many of them. One of the things when I made the little mold for the cowl, and the bottom block would continue here. This would be one flat line. That's a real easy way to do it. But one of the issues I've always had is we mount it up with a pin in the front and a bolt in the back. And this would be, I don't think it was really the best way to do it. I think a better way was the way the cardinals were mounted. And let me just, if you look at the plans even, you can see this. The cardinals had this type where there was a little piece in the back, and then I could put two screws that were in compression. So I had a pin and two screws. And I think what I'm going to do when I lay out the cal is incorporate this, even though it's a little more difficult to build. This little piece on the end, this piece, see, the problem is, well, the advantage of this is you can get the whole bottom of the plane off and get in there and work. When you have this piece stays on the plane, like on our Spitfire, the I-beam Spitfire. And then this bolt is really in a place that's not a realistic, it's going to take a beating. Over here, we can put two bolts, you're not going to see them, and get a lot better strength. This is tending to push up, and then when we want to do maintenance on this area, we can get in, and I'm probably going to make this part go back to the wing, maybe. Again, this is just one of the thoughts I've had, because I got to start thinking about how I'm going to lay this cowl out. But I think this way gives me more choices than the old-fashioned, this is the Strega Spitfire way. I think we're going to, on this ship, move on to this way. Now, it also, one of the things I want to have with this ship, even though I don't really anticipate needing it, but at some future time I might want to use this for a test plane. So I'll want to have the availability of more room for test mufflers, or if something Richard comes up with, I want to have this bottom of the plane that I can get in there. See, on Jose's plane I can't get in there because of the landing gear and because it's all sheeted up, but it limited how many muffler types we could actually experiment with. Right now, this looks like it's going to be the better of the two choices, and I'm trying to, again, build this in my mind as I go through every day, so that when it comes time to cut some wood, I have a pretty clear idea in my mind of where I want to go. And I call it building the plane in your mind before you cut wood. Maybe that'll work for you too. Now, I actually had to take a little bit of material with the belt sander right off of this edge so it would fit in, and it's going to be a nice, relatively nice, I think, nice tight fit. So what I want to do now is, before I lay out the tank floor, I want to just bolt the engine in place, get an idea how that's going to, where the header's going to wind up, and how far back, what shape I'm going to be able to make the tank box. And of course, when I'm done, I'll make a pattern for this. Now, this was a little bit of a pleasant surprise after fitting this in. This is my, well, it's a blank tank. It doesn't even have a back on it, but I wanted to see how much slop I'd have, because I originally need about 5.5 ounces, maybe 6 if we up the power of the engine. I'd like to have 6, but this is a 5, and so I know I need about another 1/2 inch. And what happens is, when I put the header spacer on and the bigger header, I still have about 1/4 inch back here. So it means I'm really only fighting for 1/4 inch. Now, as you can see in here, here's the nice thing. I can make this tank wider. I could put a little, what we call a doghouse if we really had to, but I think the easiest way to do this is going to be to put a little side doghouse on here eventually, or just make a bigger plug and make each tank by hand. But even using this, it looks like I can get a 5 1/4 in here without a problem. And I probably can get a 5 3/4 if I just take this, when I take the spacer out and put the header on the back of the motor. It requires removing some fins, of course. And maybe that's something I can get Richard to do on the motor before he sends me one. Well, we're going to have a real production motor, is take some of those fins off, put this right up there, and that allows you at least another 3/8 of an ounce of fuel. But what this confirms in my mind is we're not going to have a problem with the fuel. The fuel issue is not going to be a problem. So I feel real good about that. And I didn't know, and I'm setting this up for the worst case scenario, because worst case scenario is we want to use the bigger header, we want to use this. And so far we don't, but just in case we wanted to revert back to the original hardware, and we still know we still can get a bigger than a 5-ounce tank in, even a stock tank that doesn't have any dog houses or extensions on it. So I'm just confident that we're not going to have an issue with the tank. When it comes time to make tanks, I'm just going to have to allow that 1/4 of an inch, and I'll be no problem at all. And like I said before, and it's funny, I was surprised. I was thinking this is going to use 7 or 8 ounces of fuel. You can easily tune it to run less than 6, and 6 is it's already making way too much power. So there's a lot to be said for having a little more fuel capacity just in case. So it looks like even with that, I'm guessing you could probably, even just by putting a doghouse on the side of this tank, you could make this a 7-ounce tank. And we still have that room forward. So all of the news from this is good. There's no part of this that's a problem. So now I want to make a balsa wood plug with the thickness that it's going to allow for a shim. In other words, I want to use the shape of the tank plus maybe a 1/4 of an inch. Allow me some shim, and that'll allow me to set the tank in and use that as a little guide to get the tank floor in straight. Now I made sure I have a very accurate block. In other words, it isn't tapered going to the back or tapered going to the side, and I'm within a few thousandths. This is going to space the floor, and it's going to keep it from drifting off in every dimension. The next thing I want to do is make the pattern. It'll go right to the front for now, and then if I have to and when I have to, I'll relieve it for the back of the header. And I want to make sure this part is a perfect rectangle. I don't want it to have any taper in it. The reason for that is if I have a little bit of taper going to the front, it's going to be difficult to get the tank in and out. And I don't want to have the tank box, a thing I've run into in the past, that the tank would be sitting in the plane and either the back is up a little, the front is up a little, or it's in the plane facing the motor, and it's like that. So you get all kind of crazy scenarios. But if it's parallel to the mounts and parallel to the engine, that's a good starting point anyway. Okay, the first thing I did, I made up a little pattern oversized for the tank box floor. That'll go on, and we have to decide how we're going to make, what material we're going to use to make this. And we have several choices. But the next thing I need to do is, I left this low on purpose because I didn't know how far back the back plate of the engine would go. Yeah, I didn't want to get involved in having too tight of a clearance there. But what I should have done, and I didn't do it, is I need to bring this tank shim forward, since I'm going to be able to shim this tank right up to the back of the pads. So I'll make up a little piece of balsa wood with the either hardwood or carbon fiber right on top. Get that so that I have a perfectly flat floor in there to start with. And it'll be easier to do it now than once I put that tank floor in. Now this is one of the things, like if I had the motor, I tried to allow for that, but I allowed way too much. That's the whole problem. So I have the pattern, which I transposed onto 1/8 inch wood, and I want the grain to go side to side. This gives me the best chance of getting the corners connected. When the grain is going this way, you lose an awful lot of strength. Now I got a little piece of this carbon fiber material left. I'm going to laminate it on here, but the first thing, I'm going to cut it oversize, and then I'm going to roughen this up with 80 grit paper. I want to get a real good bond, very rough. Without the rough, if I just glue right to this, it's not going to be anywhere near as strong as if I roughen it up. Now, anytime you're going to laminate a part up, you really have to scuff any of the carbon fiber up, just like this. Just scuff it. These make great laminations too. If you could sandwich it, actually it's one of the things I could do, is sandwich it between 2 pieces of 16th, but I don't want to get into overkill here. And it's that smooth, that rough surface. The smooth surface doesn't accept the glue anywhere near as well. This has a tooth like a washboard. Now once I have that CA down, and it's kicked off. Now I need to trim this edge. Now, I don't want to be sanding this without a vacuum bench. And the next thing is to get a really, really nice precision fit. So this drops in with a press fit. Now whenever I have a carbon fiber part like this, and I'm going to put it in a plane where before it's finished, well, here's what happens. I've sanded both sides, of course, so that the glue gets a grip around the edge. But you always have this carbon dust that comes off it. Now, what I do to get around that, I've sanded it, of course, and gotten rid of as much as I can. And this is really the only way I know of to really get rid of some of that dust, and that dust can really be annoying at some point in time. And I'm on a sheet of Teflon, of course. And what this allows you to do, now you can get a good bond to it. Look at this, it's sticking to my hand. Now I'll do this 2 or 3 times until I get a coating of CA on here. Get rid of a little piece of glove. But now what'll happen is when I go to sand that, it's not going to give me all of that black goop that comes off. I made up a little piece of shim for that little piece that's going on the front of the motor mount. Just was a miscalculation on my part. And with those 2 little pieces in place, now this is continued out at exactly the same height. Now I'm ready to put the tank, that little piece in, and I need to allow for the tank shim. I'm going to have a similar way of mounting this. I'm going to try a way of mounting the back of the tank where I have a screw and a little slider that I can use as a shim. Because remember, on the carbon fiber tanks, you really can't realistically shim them in the middle. You got to shim them on the end caps. Now that's going to allow me, when this is in place, I'm going to be able to locate somehow, and I don't know exactly where, as low as possible I guess would be the best, another blind nut. And I'm going to have to look at exactly how I want to do this. I can let that go. I don't need to do that right now to get this in place. But I'm going to have some way of probably a little, and because this will be all open, I'll be able to get a blind nut in there. And then I can put the tank in place. Once the tank's in place, I can have a little L-shaped bracket that slides up and down and acts as a shim and never have to glue it. So that might be, and I don't need to do it right now, so that gives me some time to work on that. Now, I was real careful. With the micrometer, I made sure this was exactly square. So once this is in place, that's going to locate my tank, and it's going to hopefully keep it 90 this way, this in every dimension. Now that block right off the mounts is going to hold that. Now what I'm going to do is just put a few tacks on here because I don't want to take a chance I'm going to glue that block in. Then I'll take that block out, run a glue seam front, back, and we'll have a permanent tank floor. Then whatever clearance I need to make around here for the header, I can drop the engine in and just start making a little bit of clearance here. And one of the things I like about having this little system of doing the shim, in the past we'd have to shove the shim in, hammer it in, sometimes like what happened to Chris Rudd or Rich Jacobone, it goes through the tank. What this is going to allow us to do, if I didn't glue that shim in place, is just I can get behind here and just get the tank started out rather than the old-fashioned way where you had to pull on the vents and everything. This is really a nice way to do it. I can push the tank in, shim it up and down this way, and when that's in its final, and I'm not sure exactly how I want to do it yet, but I don't need to know right now this afternoon. But I know I can get the tank in and out that way. That'll be very handy. So now the next thing is to put a permanent glue seam on that. Then run a glue seam on the inside of the tank, and that part will be in there permanently. And I just have to figure out the clearance issue if we're going to have that stock header. Now what's really handy here is I can actually see the glue go down, go across. So I know I'm going to get some good penetration. Let it work down into the corners. And even this part here of just letting it run right inside the tank box. Let it go all the way down. And once this piece I'm sure is really nice and solid in it, then I want to make a little gusset along the edge. And I hope that's going to really serve us well. That really, and now if you were to grab this right now, this is as solid as a rock. This is amazing how quick that completes the box. And now we've got a nose section. Those seams worked out real nice. Now, but I always like to make, I get a piece of soft balsa, 1/4 inch square, and kind of pre-carve a fillet. I like to get a fillet in there. Just to keep that joint. That joint is one that always takes a beating from oil and fuel, and once this loosens up and the part behind it, that joint isn't good. There's almost no possible way to repair it. So it's kind of cheap insurance just having those two pieces in there, and I've had them in on most of the planes and they've really served me well. Now we can set up our stripper for about a 1/4 inch square cut. And just use up what amounts to be a piece of scrap here. That's why I always save the scraps of the really reasonable wood. Something like this I can use them for. And that strips me off a nice piece of 1/4 inch square. Now any kind of reinforcement here, I would just like to get some of this material off. And I can get the last little bit off once it's in place. Actually, you could get it all off when it's in place. This is just, I'm just trying to make this a little easier for myself. And you notice I stripped off a lot more than I needed. Well, because I usually make 4 of these before I get one that isn't broken. But these are nice little reinforcements. It's a nice little way to do it, actually. But it's delicate, that's for sure. And once I get most of the meat removed with the gouge, I've got most of the material removed, but not all. I can go to my little sanding, little things that have a shape that I want to use. Now we got all these shapes, these polywog shapes with reverse curves, and the only trouble is this one's a little bit too big, so I'm going to have to make one the diameter that I want. Now because this one here, this is square, I can just take and make the radius that I want. It's only rubber, it carves just about the way balsa wood does. And instead of putting a sandpaper on this edge, I can just put it on this edge. So you get double use out of these tools. Now here's a good little tip when you want to get that radius in there is take one of your sanding blocks if you can. The sanding block kind of, I'm not sure I'm making my point at. The sanding block holds it in shape while you do your final shaping. And if you remember back to like the Sidewinder videos, we made the fillets out of balsa wood this way, pre-carved the fillets. Just one other way to do it. And you can reverse it and just do it both ways. Then what the sandpaper does, the sandpaper helps hold it in place. It's really a nice little feature to have the sandpaper there. And what you do when you triangulate a joint like this, you add a tremendous amount of strength, and both of these pieces when they're done won't add 1 gram of weight. They'll add a fraction of a gram, but they'll definitely add some rigidity. And you can see we've got almost like making a gutter for a dollhouse. And once that piece is glued in, you can do a final sanding. Get a real nice radius edge there, and we'll just do the other side. And we basically have one of the key components that makes for I think, a really good nose construction. Getting that tank floor in solid. And that's how the Spitfires are done, and that, I think that little piece there, that really does add some integrity. Now the next thing on this whole deal, I've got to make allowances for the clearance on the bigger header, and you can see where this is one that's been used, but I still need to know this clearance here in case I want to use the standard parts. I want to have clearance for the standard parts no matter what, and I can see right now that I need about 3/8 of an inch of clearance there. So I don't want to build myself into a corner where I can use some headers and I can't use others. I want to have as many choices as possible when we actually come to flying this plane and trimming it out. And one of the other clearance issues I'm going to need to deal with is I'm going to need to be able to get the tank in and out. And see, when the nose ring is on, that's going to require maybe removing a little bit more of this material here. But again, I can't tell until I actually get the nose ring in place. I'm just trying to estimate where that would be. That would probably be a clearance issue. But because this part that we put in, this tank floor, is so strong, just cutting some of it away is not going to be a deal breaker. Now I still want to have even extra clearance even after I get done with this. And it looks like that's the amount we need. Now remember, I got to get air going around there. That's the hottest part of the engine also. That's another issue I have to deal with. And that looks like that'll allow me some air in there, among other things. And I can taper this back just a little more, and I'll have it. A good way to dress this off, I just have a jar, this epoxy bottle. And I'll seal this whole edge with thin CA so it's relatively fuel proof, not prone to getting oil seepage. And this looks like it's going to give us exactly the clearance that we're going to need. That really was a satisfying step to get done, because that changes, the whole scope of everything changes. Now all the structure is in the nose except for the nose, and the nose is rock solid. And we're well within the weight parameters that we usually are at this point in fuselage construction. At the time that we're things we until we get that part from